So a few opening notes. One is that you're probably going to need scratch paper. So scratch paper. There will most likely not be enough space to fit in all of these problems since you're drawing graphs, you're doing some calculations, you're writing equations. So get out the scratch paper. The second thing is that we can change our standard form a little bit to make these problems easier. So watch how I do this. It starts the same, y equals a times sine of b, but then I take the x minus h and I put it in its own set of parentheses. So effectively I'm factoring out the b value here, and when I take the b out, now this h will directly tells us horizontal shift. So I don't have to worry about that formula h over b if I write it like this, and then plus k is still the same. Another thing is just have a sense of what sine and cosine look like. Cosine starts at a maximum, so cosine of x starts at a max. And sine of x, kind of looks like that, starts at a midpoint. All right, this is sine of x. All right, so I'm going to go ahead and talk about problem number 1. Problem number 1 asks us to write a trigonometric equation for the function with a period of 6. The function has a maximum of 3 at the value y equals 2 and a low point of -1. Because I've got a maximum, and we remember that maximums happen, or maximums are the starting value of cosine. I know that I want my parent function here to be y equals cosine of x. Next thing is I'm given the period. The period is 6. Well, here we do need a formula to find b. If the period is 6, I know that 2 pi over b will calculate for the period. So 2 pi over b needs to be equal to 6. Here I'm going to multiply b to both sides. So now I've got 2 pi equals 6b. Divide both sides by 6, and I'll get 2 pi over 6 equals b. I can go ahead and simplify that by dividing the top and the bottom by 2. Now let me write this on the other side so it doesn't look like I'm doing 2 divided by that. So divide by 2, divide by 2, and I'll get pi over 3 equals b. So I've got b, I've got my parent function. Now let's talk about this. Maximum of 3, low point, or we could also consider that a minimum of -1. So to get a max of 3 and a minimum of -1, that will give me 2 pieces of information. It's going to tell me the amplitude as well as the vertical shift. So to get amplitude, we could do max plus the min. Well, 1 second. Yes. Max. No, 1 second. We want the difference in the maximum and the minimum divided by 2. So max minus the minimum divided by 2 equals amplitude. So 3 minus a -1 equals 2. 4 over 2, our amplitude is 2. So that tells us our A value. And now for the K value, that's the phase or the vertical shift. That one is max plus the minimum divided by 2. So we're effectively averaging this to find our midline. And so the maximum is 3. We add our minimum of -1 divided by 2. We'll get 2/2. This equals 1. So this is our K value. This makes a lot of sense to me. If I shift my midline up to 1 and then have an amplitude of 2 on top of that, my maximum will be 3. And if I have an amplitude of 2 below that, well, 1 minus 2 brings us down to -1. Now, let's put together what we have so far. Y equals 2 cosine, parentheses, pi/3 x, leave a blank to fill in that h value plus 1. All right, so here a diagram might be kind of helpful. Let's see. Our cosine graph used to look like this. All right, it had a maximum at 0, and then we applied all of these shifts, but none of these shifts affected the fact that the maximum would still be at 0. Now I want a maximum to occur at x equals 2. All right, so the maximum was at 0. Now I want the maximum to occur at x equals 2. All right, so I need to shift right 2 units. So that now our cosine will look maybe a little bit more like this. Now, right is a positive number, but the formula already has a minus built in. So I'm going to do -2 so that this shifts us 2 units to the right. And that's our whole equation. All right. That looks good. Kind of want to double check that one. Yeah, I simplified this here. -2, good. All right, so pause now and try problem number 2, and then unpause it, and I'm going to write up the answer to number 2. All right, that is our answer to number 2. Notice we were shifting the low point. This actually kind of created a tricky situation because after we'd done these first couple transformations, we would have a cosine wave that kind of looks like this, maximum here, coming around to a maximum. It told us to make the period equal to 5. So if the whole period is 5, the low point has to be happening at 2.5. That's why we shifted left 1.5 to put the low point at the right location. All right, so that was number 2. Hopefully you did all right on that. I'm going to explain number 3, 4, and 5, and then you can try 6 and 7 on your own. So for number 3, Ruby has a pulse rate of 73 beats per minute and a blood pressure of 121/85. This means when the heart is contracting, the blood pressure increases to a maximum of 121, and then when it relaxes again, the blood pressure dips to 85. This is actually pretty decent blood pressure. Ruby should try and get this below 120, though, so doesn't have to worry about hypertension later on in life. All right. So I think a diagram might be helpful. Would be, let's draw an X and Y axis, and let's draw horizontal lines in at 121 and 85. All right, I want my blood pressure to just oscillate between these numbers. The heart contracts, I'm up at 121, it relaxes, I'm down at 85. Up and down it goes. All right, how often do I want that to happen? Well, I want it to happen 73 times in 1 minute. So 73 cycles in 1 minute. So from here to here times 73 in 1 minute. So if this is going to happen 73 times in 1 minute, the period needs to be 1 over 73, 1/73 of a minute per cycle. That way we can get 73 of them in 1 minute. So I've got the period. I can now solve for B because I know that period is equal to 2 pi divided by B. So set that equal to 1 over 73. I'm going to cross multiply here, and I'll get 146 pi equals B. So now I've got B. I can find amplitude by doing maximum minus the minimum. Divide that by 2. I'm going to have to grab my calculator on this one. 121 minus 85 is 36. Divide that by 2 is 18. So 18, that's going to be my amplitude. To find my midline, well, one idea is that if 121 is my maximum, and my amplitude is 18, I could just do 121 minus 18. 121 minus 18 equals 103 for my midline, which is also my K value. Just write B, my K value there. Let's see, I've got A, I've got B, I've got K. And as far as H is concerned, it doesn't give us a starting value or anything like that. So we're just not going to use it. We'll just have Y equals 18. No parentheses yet. We'll pick sine, it doesn't matter, of 146 pi times x. I don't even need that parentheses there. I'll just say 146 pi x plus 103. Let me check my notes on that one. Looks good. Yep. All right, moving on to problem number 4. A mass suspended from a spring is pulled down a distance of 2 feet from its rest position. The mass is released at time t equals 0 and allowed to oscillate. If the mass returns to this position after 1 second, find an equation that describes the motion, then find at what, and it says 2 times, let's just find at what time within 1 cycle is the spring at 1.5 feet above its rest position. It does later on, perhaps next unit, I'll want us to be calculating more with inverse trig. If we can just do this one inverse trig problem, I'll be pretty happy. All right, so we'll say the rest position is just represented by y equals 0. This weight is pulled down 2 feet below that, so it's down here -2, and then it's released. And it goes up. We're going to assume it hits a maximum of 2, and then it comes right back down it hits that minimum again after 1 second. So 1 full cycle here after 1 second. And then it's going to do a whole bunch more. So 1, 2, 3. All right, let's start filling in the values. It's easy to tell that my amplitude here is 2 and my k value is 0. This hasn't been shifted up or down at all. The period, it went from a minimum, a trough to a trough in 1 unit. So I know the period equals 1, which equals 2 pi over b. I can just multiply b to both sides here, and I'll get that b equals 2 pi. So now I've got my b value. And now I'm missing my h value. Does it tell us if it wants sine or cosine? It doesn't. Because we have information about a minimum, I'm going to go with cosine. Cosine starts at a maximum. So being at an extreme end, I think we'll be able to more easily shift this over. So if the weight's able to go from a minimum to a minimum in 1 second, it must hit its maximum at a half a second or 0.5 seconds. And so if our cosine normally has a maximum at 0, I've got to shift that to the right 0.5, so right 0.5 units. To move to the right, my h will be 0.5, but remember the formula's got that minus built in. So let's write this out as y equals 2 times cosine of 2 pi in parentheses x minus 0.5. So the minus always moves it right. It's kind of always opposite what you think. And we can end it there, that we don't have a k value. Let me check my notes on that one. 2. Oh, I did this with sine in my notes, but I think that's fine. One thing I noticed is that it tells us to use the variable t for our independent variable. So technically, to be totally right, we need to swap this x for a t. And it doesn't, yeah, I think we can just use y. It doesn't give us a prescribed dependent variable. All right, moving on to number 5. A city averages 14 hours of daylight in June, 10 in December, 12 in both March and September. Assume that the number of hours of daylight varies sinusoidally over a period of 1 year. Write an expression for n, the number of hours of daylight, as a cosine function of t. Let t be in months and t equals 0 correspond to the month of January. All right, let's graph this to the best of our ability. I'll put my y-axis will be days of sunlight. X-axis is the month. It says January is 0, so I'll put like a J here, right at 0. And then I'm just going to start listing off my months the best I can remember. January, February, March, April, May, June, July, August, September, October, November, December, January again. All right, below those I'll put a number, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So it gives us some points. 14 hours of daylight in June. So June, that's right here. We're up at 14. 10 in December, so in December, we're right here at 10. And in March and September, we're right at 12. So we can assume that January is the, or June here is the most daylight, and December is the least daylight. Or let's connect these dots up. So there over the spring, daylight gets more. As we go to the winter, daylight gets less. Let's see. We can add in our midline. Our midline is at 12. That gives us our K line. So K equals 12. From 12, we go a distance of 2 to get to our maximum. So we know that A is equal to 2. We can see that the period is equal to, well, actually, I put my line in the wrong spot. Period is for a full cycle. That's just midpoint to midpoint, what I've drawn. Period should be from January to January, which we know is 12 months, so the period equals 12. Let's just do that calculation real quick. So 2 pi over b equals 12. Multiply b to both sides. 2 pi equals 12b. Divide both sides by 12. And we get pi over 6 is equal to b. What else are we missing? We're still missing h. So I'll use a cosine graph, which normally has its maximum at 0. And now I'm going to just shift that maximum over here to June. That is 1, 2, 3, 4, 5. So my h value is going to be equal to 5. I'm shifting my peak 5 units to the right. So I've just got to write an equation for this now. Y equals, my A was 2. I'm using cosine. My B value is pi over 6. Extra parentheses there, so I can just do directly x minus 5 for that horizontal shift 5 units to the right, plus my K value, which was 12. All right, I see this problem also asks, what is the average amount of daylight in August? This is reminding me that I skipped the end of this problem here. I'm going to come back to it after we finish number 5. Let's see. August. August is month number 7. So y equals 2 times the cosine of pi over, that's a 6. I made it look like a b. Pi over 6. A value is 7, so 7 minus 5 plus 12. Y equals 2 cosine of, that'll become a 2. 2 pi over 6 is the same as pi over 3. Plus 12. Y equals 2 cosine of pi over 6. Hopefully we'll have this one almost memorized by now. A 60-degree angle is going to have an adjacent of 1 and a hypotenuse of 2. So cosine of pi over 6 is 1/2. Or cosine of pi over 3, that is. Let me just double check that. Yeah, 1/2 plus 12. Y equals 1 plus 12. So August will have 13 hours of sunlight. "13 hours." All right, so that reminded me I needed to go back. We need to calculate when the spring was going to be at 1.5 feet. To do that, we plug that in for y. So I need to put a 1.5 here equals 2 cosine, all this stuff. Let me bring up my on-screen calculator to solve this one. So I need to get t by itself. What I'm going to do is I'm going to divide 2 from both sides. So I've got 1.5 divided by 2. So that gets rid of the 2. Now to get rid of the cosine, I need to take the inverse cosine. So second cosine of second answer equals that decimal there. Now I got to get rid of the 2 pi, so I can divide this by, in parentheses, 2 pi. And then at the very end, I need to get rid of that minus 0.5, so I'll add a 0.5. Then we get that at 0.61 seconds, the spring will be at 1.5 feet. So 0.61 seconds, it'll be at 1.5, which it corresponds to this point right here. To get this point over here, we're going to need to learn more about inverse trig. All right, why don't you work on 6 and 7. So pause the video here, work on 6 and 7. I'll write up the answers to those. Number 6. That's a T. All right, check your work on those. We'll do number 8 now. The electric current alternates at a frequency of 60 cycles per second, and they're very nice to give us this formula here. Frequency equals 1 over the period. It tells us, so frequency is something like this, 60 cycles per second. It tells you the amount of something over a given amount of time. So beats per minute is another example of a frequency. So we can find the period. So 60 is equal to 1 over the period. We just rearrange this to get that our period is 1 over 60. This is called quite aptly alternating current in this type of electrical system we have in our homes and offices in the United States. Suppose that at a time t equals 0.01 seconds, the current is at its maximum of I equals 5 amperes. I is a common variable used for current. So here we need a little graph of this. Like this. At 0.01, we need to be at our maximum of 5. Now it doesn't say this, but the minimum is 0. It's going to come all the way back down to 0. So it's going from 5 to 0, 5 to 0, 5 to 0. And it's doing it really fast. So this is just going up and down super fast. All right. If the current varies sinusoidally over time, write an expression for I amperes as a function of t in seconds, and then we're going to figure out the current at t equals 0.3. So let's see what I've got to do. I've got The period is 1 over 60. I've got to find my b value. Period is equal to 2 pi over b. I'm going to cross multiply here to get that b is equal to 120 pi. If I wanted to put a midline in, I think it's probably pretty clear that that midline would be at 2.5. So that gives me my k value. And then the distance from my midline up to the peak is also 2.5. So 2.5 equals my a value as well. Now I'm going to use a cosine because I know that I've got a maximum here. So cosine normally has a maximum at 0. It's been shifted right 0.01. So that gives me my h value. Now I'm ready to put this all together into an equation. So I for current equals my amplitude 2.5 times, I said I was going to use cosine, so I could just shift its maximum, of 120 pi, parentheses, x, I moved it to the right, so it needs to be minus 0.01 plus 2.5. Now let's answer the question, what is the current at t equals 0.3? So I'm going to plug in 0.03 right there. I'll just use my on-screen calculator for this one as well. So I can do this all in one line if I want, as long as I do my parentheses right. 2.5 times the cosine of 120 pi times 0.3 minus 0.01 plus 2.5. We get that we're going to have about 0.477 amperes of current at that time. So 0.477 amps. All right, go ahead, pause now, try number 9 on your own. Then we'll talk about number 10. All right, there's number 9. All right, so for number 10, an object attached to a spring oscillates around a stable equilibrium position according to the position formula given by S of t equals 8 sine of 3t, where t is in seconds and S of t is in feet. What is the period, frequency, and the maximum displacement for the stable equilibrium? So for period, we know that period equals 2 pi over b. I can tell that my b value is 3 here. So the period is going to equal 2 pi divided by 3. All right, one down. Frequency, we got this formula. Frequency equals 1 divided by the period. So the frequency here is going to be equal to 1 divided by 2 pi over 3, which if we copy dot flop that becomes 3 over 2 pi. Okay, another one down. And maximum displacement, that is equivalent to amplitude, which we can just see is right there, a equals 8. So max displace equals 8. All right, so problems 11, 12, 13, and 14 are homework, and they're going to get their own video. It'll just be a homework help video.